So in this example here, we have two things that we're multiplying together. We have an h plus 7, which is how many terms? 2 terms. And we're going to call that the height, and that's why the picture that we have has two rectangles high. And then we're multiplying that by 2h minus 5, which is how many terms? 2 terms. So that's why we have two rectangles wide in our picture. All right, so the number of terms tells us how many rectangles tall and how many rectangles wide our picture needs to be. All right, so now we're going to label our picture. Since the height is h plus 7, where am I going to put those? I'm going to put those along the side here, right? So the first one is going to be h, the top part, and the bottom one is going to be 7. So that the whole thing, the entire height there, is h plus 7, all the way down there, right? Okay, and then the width is going to be 2h minus 5. So where is the 2h going to go?
On top.
It's going to go there. And then what do I do with that negative 5? It's a minus 5, so it's negative, right? Should I make this just a 5, or what do you think?
Put the negative.
Yeah, we're going to put a negative on there. One thing I want you to keep in mind is next year when you take geometry, there's no such thing as a negative length. If you measure how long something is, it's always positive. That's actually the whole idea of absolute value is it's a distance, and distance is always positive. But since we're using geometry to help us with an algebra problem, and in algebra we can have negative numbers, we're going to let that length be negative and just see what happens if we let it be negative. All right, so when we do that, we get a width of the whole thing that is 2h minus 5 when we combine those together. Okay, everybody okay with that setup? So then we just go through and we find areas like we did before. To find the area of each one, we're going to use that area formula, height times width. All right, so what is the height of this rectangle right here? H. And what is the width? 2h. Now, to multiply this together, it might be nice to have a coefficient, a number in front of that h. What is the number in front of h here if there's nothing there?
1.
That's a 1, right? So I'm going to put a 1 there. You don't have to do that, but just keep in mind that if there is no coefficient, then the coefficient is 1. And that'll help with just kind of thinking about what the number is going to be here. So when we multiply 1 times 2, we get 2. And then we multiply the h times h and get h squared. So the area of that first one, that top left one, is going to be 2h squared. All right, the next one, what's the height? H. Remember, that's a 1h, right? If you want to put that 1 in front, that might help out. And then what is the width? Negative 5. Okay, so when we multiply 1 times negative 5, what do we get? Negative 5. And then we have that h on there, right? So this is another geometry thing that's not really allowed, but since it's an algebra class, it is. When we find the area of something, remember, area is counting how many squares cover a shape. And so if we're counting how many of something covers a shape, it couldn't be negative, right? So if we're just talking about area, we're not allowed to have negative areas. But since it's an algebra problem, we're just using the geometry to help with algebra, it's okay to have a negative area. Okay, and actually, this area might be positive if h is negative. Because if h is negative, then it's a negative times negative, that gives us a positive. So it might not even be a negative area. How about this one? Height? 7. Width?
2h.
So we have 7 times 2h, and that gives us an area of
14h.
14h. And then the last one, the height is 7, the width is negative 5, and that gives us a total area there of negative 35. And again, remember, geometry areas can't be negative, but we're using this to help us with an algebra problem, so that's okay. So to find the total area then, what are we going to do? We're going to add them all together, right? When we add them together, we've been doing this. Which one's going to go first?
2h squared.
The h squared, right? So we're basically putting them in order with the most h's all the way down to the fewest h's. So the one with the most h's is the h squared. So that's going to go first. So I'm going to put an equal sign up here next to the problem. And we're going to have that 2h squared. That cannot combine with the other h's, right? Why can't it combine with these other two h's? Yeah, because of the square, right? All right, now, here's a kind of tricky part. We're going to combine this 14h and the negative 5h, but since one's positive and one's negative, we're not going to add them, right? What are we going to do? We're going to subtract. What's 14h minus 5h? 9h. All right, so if we have 14 positives and 5 negatives, the 5 negatives cancel out with 5 of the positives, and we're left with 9 of the positives left. So we get plus 9h there. If the negative one was bigger, then it would be a minus instead of a plus, right? And we're going to see that happen quite a bit. And then the last one, we're going to add on the negative 35, but if we add a negative, it's the same thing as subtracting the 35. And there's your answer. This next example here looks a little different, right? I like this one. Go ahead and write the problem down. In this problem, it looks different, but I'm going to tell you right now it's the exact same kind of problem. We just need to write it a little bit differently. We don't want to leave it like this. So let's talk about what this square right here means. All right, and to do that, let's just do this. I'm going to say 5 squared. What does 5 squared mean? That means 5 times 5, right? Which is 25, but that doesn't really matter. What does x squared mean? It means x times x, right? So the square, the exponent, means that we're multiplying the same thing by itself. In this case, since it's a 2 times. All right, so this problem here, that square means that we're going to multiply 2j plus 7 times 2j plus 7. So this is the same thing, the exact same problem as saying 2j plus 7 times 2j plus 7. Now, if I write it like this, then it looks more like the last problem, right? Yeah. So by writing it like this, now we have a height here, and we have a width right here, and we can label those things in the picture, find the area of the picture, and get our answer. Go ahead and give that a try on your own. Finish that up. So we want to label our height and our width here. So I'm going to label the height going down the side. The top part I'm going to make 2j. The bottom part I'm going to make 7. I don't need to put a plus in front of it because if there's nothing in front, we know it's positive, right? And then the same thing going across. I'm going to make this a 2j, and I'm going to make this a 7. So we really have the same height and the same width. So by having a square here, what happens is this right here, this height is the same as the width, and it's actually a square. Remember, a rectangle that has the same height and the same width is just like the tiles on the floor. They're squares. That's why we call this a square. All right, so we want to find the area of each of these smaller rectangles. This rectangle right here has a height of what? 4j. What's the height of this rectangle? 2j. And what's the width? 2j, and that gives us an area of 4j squared. Okay, this one has a height of 2j, and it has a width of 7, gives us an area of 14j. And when we have problems like this with squares, you guys are going to notice that we're going to get the same area for this one as we got for this one. So what we end up with is a height of what? 7 and a width of 2j. And so we get the same thing we got here, even though they're in a different order. 7j. Let me try that again. 7 times 2j is the same thing as 2j times 7, which is 14j. And then this bottom right one here, it has a height of what? 7 and a width of what?
7.
What do we call a rectangle that has the same height and the same width?
Perpendicular?
I just said it. Starts with an S. Square, right? So this is actually a square right here, this little one here. This is a square right here because the height and the width are the same. And the whole thing is a square because the height and the width of the whole thing are the same. What is the area of this one? 49, which just happens to be a perfect square, right? Man, squares are fun. All right, so we're going to write our answer. You may not have enough room off to the side to write it like I'm going to here, so maybe try to squeeze it right underneath, put an equal sign underneath, and write our answer there. What's the first term going to be in our answer?
4j squared.
Okay, so that's the one with the most j's, and then the next one we're going to combine the j's here. 14j plus 14j is 28j. And then the last one we get plus 49. Now I said that 49 is a perfect square. It actually turns out, because we got this by squaring this, that this whole thing right here is also a perfect square. That's kind of an advanced algebra thing, but if we add all three of those together, it's also a perfect square, meaning it's something that we could take the square root of. Not really important for what we're doing right now, but just kind of a fun fact. All right, moving on. Maybe. So in example 5 here, I think you know enough to be able to do this. This is example 6, isn't it? No. Mislabeled. Go ahead and give this one a try on your own. Just like all the other problems, we're going to label the height with our first factor, that's 2k plus 5, and we're going to label the width with the second one, which is the 2k minus 5. Now, there's something special going on here. I want you to notice that the first factor and the second factor are exactly the same except what? One's a plus and one's a minus, right? A negative. So because of that, because it's the same but just opposites, it's a plus 5 and a minus 5, we're going to get something kind of fun happening here. So we're going to label 2k and 5 here. We're going to label 2k, and don't forget this is negative, so negative 5 here, and find the areas of each one. Remember, we should have 3 things in each rectangle. The first is the height, which is 2k. The second is the width, which is 2k. And then the third is the area, which is 4k squared. So there's the 3 things we need in that rectangle. Moving over here, what's the height? 2k. What's the width? Negative 5. What's 2k times negative 5? Negative 10k. Okay. Then we move down here. What's the height? 5. What's the width?
2k.
2k. What's the area?
10k.
10k. All right. And then the last one. What's the height?
5.
What's the width?
Negative
5 times negative 5 gives us an area of negative 25. Don't forget to make that a negative. A positive times a negative is a negative. All right, so now we're going to combine these. We're going to add them together to get our final answer. So I'm going to put my equal sign up here next to the problem and then write my answer right next to that. And the first one we're going to do is the one with the most k's, the k squared, which is 4k squared. Then we're going to do the one with just the k's. It's going to be these two combined. Have you guys noticed that when we do these, it's always the top right one and the bottom left one that combine? It's almost always going to happen like that. So it's a pattern that you can look for and make sure that you get that. What happens when I combine a positive 10k and a negative 10k? It becomes a 0k, right? So a positive 10 and a negative 10, or in this case a positive 10k and a negative 10k, they just cancel each other out. So should I put plus 0k in here? No, we don't even need it. If they cancel each other out, it's gone. So these are just, forget about them. All right, so then that leaves just the last one, which is, that leaves the last one, which is minus 25. So most of the problems we've done, in fact, all the ones we've done like this so far, we had 3 terms in our answer, but this one only has 2 because those terms with just the k cancel each other out. And that's going to happen anytime the problem looks like this, where it's the same, except one's positive and one's negative. In these last 2 examples, I want you to look at your notes right now and tell me what's different about these last 2 examples from the rest of them we've done. There's no picture, right? So what are you going to have to do? Yeah, you're going to have to draw your own. So let's talk about that real quick. In this one right here, be careful. Don't draw the picture yet. Let's talk about it and make sure that we get it right. We want to use a rectangular model to help us distribute this 3 times the quantity 2m plus 8. So what I'm going to do here is I'm going to label the height and the width. And again, you don't need to do this. I'm just doing it so we can kind of see how it's going to turn into an area problem. And what do you notice about the height and the width? Specifically, how many terms are there? How many terms are there in the height?
1.
Just 1, right? So how tall or how many rectangles are we going to need going up and down? We're only going to need 1, right? So this is going to look more like our first 2 examples, example 1 and example 2, more than examples 3 through 6. All right, so it's only going to be 1 rectangle tall. So what I'm going to do is I'm going to just draw a line going up to show that we're going to have 1 rectangle going up. And then the width has how many terms? It has 2, right? So going across, I'm going to need to split it up. So what we end up with is a picture that looks like that. again, what we're looking at is the number of terms in each factor. When I talk about the factors, it's the things that we're multiplying together. So in the first factor, for the height, we have one term, so we only make it one rectangle tall. And then in the second one, for the width, it's two terms, so we're making it two rectangles wide. We could really have as many terms as we want in each of those factors. We've only done 1 by 2 or 2 by 2, but this could have 7 terms in it, and this could have 12 terms in it. And then we would have 7 rectangles high and 12 rectangles wide. That one sounds pretty fun, right? And we'd have 84 areas defined and add together. We're not going to do that to you. All right, so let's go ahead and finish this up then. The height is going to be 3. The width is going to be, help me out, 2m and 8, right?
Yeah.
So then we find the area of each one of these individually. The area of this one is going to be the height times the width. What's the height?
3.
What's the width?
2m.
And the area then is
6m.
6m. All right, then this one here, what's the height? 3. It's the same as the height of the one next to it, right? And then the width? 8. And that gives us an area of 24. So then the whole thing, I can write this up here next to this. The whole thing has an area of 6m plus 24. We can't combine those because one has an m and one doesn't. Okay, so in the last example, how many terms are in the first factor? 2. How many terms are in the second factor?
2.
So what's this going to look like?
2
Square.
boxes.
It's square, but it's gonna have 2 boxes.
Yeah, it's going to have 2 going up and down, and it's going to have 2 going side to side. So go ahead and give this one a try. Draw a picture. It's going to look more like examples 5 and 6 that you have at the top of this page, rather than examples 1 and 2 for the last one. And then go ahead and finish it up. We have 2 terms in the height, so that means that the rectangle is going to be 2 rectangles tall. So I'm going to do this to show that. And then we have 2 terms in the width. So it's going to be 2 rectangles wide. I'm going to do that, and then just fill it in here. And then we'll label them 5n, -2, don't forget the negative on there, 3n, and 4. So then to find the area of this first one here, what's the height? 5n. What's the width? 3n gives us an area of 15n squared. All right, how about here? What's the height?
5n.
What's the width?
4.
5n times 4 is 20n. All right, next one, what's the height? 2, right? What's the width? 3n. What's -2 times 3n? -6n. And then the last one, what's the height? -2. What's the width?
4.
What's the area?
-8.
And so to answer this question then, we're going to add all those together. What's going to go first? 15n squared. Then we're going to have the n's. Notice that one's positive, one's negative, so they're going to be canceling each other out. We're going to subtract. What's 20n minus 6n? Plus 14n. More positives and negatives, that's why it's positive. And then minus 8. A few things to keep in mind. All right, and I'm going to talk about a little bit of it while we have this up here. Notice that in every rectangle, every small rectangle, how many things do we have? We have 3 things, right? So we have the 5n, which is what? The height. The 3n, which is the, and the 15n squared, which is the area, right? The answer, which is the area. So one thing that you need to make sure you're doing when we do this is show all your work. Okay, that includes in these problems labeling the heights and the widths on the outside, and then inside of each rectangle indicating what the height is, what the width is, multiply them together to get the area. All of those things need to be in there for your work. You also, in these problems, want to write your answer right next to the problem, because the answer is what we get when we multiply these 2 things together. So they're equal to each other. We want to show that by putting them next to each other with an equal sign. All right, a couple other things. When there's more than one variable, so say we have A's and B's in a problem. We haven't seen that yet, but if it happened, what would we do? Which ones would we write first, A's or B's?
A.
A's, why?
Or B.
Because it comes before a B in the alphabet, right? So we're going to write the terms, if necessary, if there's more than one variable, in alphabetical order. When we have the same variable, and this has happened, we have the same variable but with different powers. So we have an x, which would be x to the first power, and an x squared. Which order do we want to write the terms?
The biggest.
Yeah, we want to write the exponents from biggest to smallest. So we're going to write the terms from largest, I'm going to use the word largest here, largest exponent to smallest. And this last thing I talked about already, be sure you show all your work. Be sure you're labeling everything in the picture that you should. And make sure you're boxing your answers just like we always do.